the universe has always been a realm of endless curiosity and mystery for humanity. From the earliest moments of recorded history, people have looked up at the night sky, wondering about the stars, the planets, and the forces that govern them. As technology has advanced, so too has our ability to peer deeper into the cosmos, unveiling secrets that were once unimaginable. Yet, despite our progress, some of the most fundamental aspects of the universe remain as enigmatic as ever. One of the most perplexing discoveries that has emerged in recent years is the presence of enormous cosmic voids, vast expanses of empty space that defy our previous understanding of how the universe is structured. These voids, stretching millions of light years across, present a huge challenge to our scientific models and theories. What do these voids mean for our understanding of the universe? Are they just strange anomalies, or could they be key to unlocking some of the greatest mysteries of existence? In 2021, the launch of the James Webb Space Telescope brought an unprecedented level of detail to our exploration of the universe. Designed to observe the cosmos in infrared wavelengths, this advanced telescope has already provided us with images and data that have dramatically expanded our knowledge of space. But one of the most startling revelations from the James Webb Telescope has been the discovery of vast voids, areas of space that seem to have no galaxies, no stars, and almost no matter at all. These voids are some of the largest structures in the universe, measuring hundreds of millions of light years across. To put that into perspective, if a beam of light were to travel from one end of the largest known void to the other, it would take 100 million years for the light to cross that distance. Such immense, empty regions were not something scientists had anticipated finding in such large quantities, and their discovery is challenging our most fundamental ideas about the cosmos. For decades, scientists have been working under the assumption that the universe is structured in a relatively uniform and predictable way. The cosmos, according to this model, is filled with matter, energy, and galaxies that are distributed across space in a somewhat even manner. This view was bolstered by the work of Edwin Hubble in the early 20th century, who first observed that galaxies were moving away from each other, suggesting that the universe was expanding. Hubble's work laid the foundation for the Big Bang theory, which posits that the universe began as a singularity and has been expanding ever since. According to this model, the universe is homogeneous, meaning that it looks roughly the same in every direction, and isotropic, meaning that it has no preferred direction of expansion. This idea was further supported by the discoveries made by the Hubble Space Telescope, which gave us a clear picture of how galaxies are distributed across vast stretches of space. But the discovery of these enormous cosmic voids throws a wrench into this long-held understanding. These voids, which seem to stretch for unimaginable distances with no galaxies or other matter in them, challenge the very concept of a homogeneous and isotropic universe. If the universe is supposed to be evenly distributed with matter, how can such vast regions of emptiness exist? This question has left scientists scrambling to rethink their models of the cosmos. Could it be that our understanding of how the universe is structured is flawed? Or is there something more complex going on beneath the surface of these discoveries? At first glance, voids might seem to be just empty space, regions where there is simply no matter. But a closer examination reveals that these voids are much more than that. In many ways, they are the perfect counterpoint to the dense clusters of galaxies that fill the rest of the universe. The large-scale structure of the universe is often described as a cosmic web, with galaxies and galaxy clusters connected by vast threads of dark matter and gas. These threads, known as cosmic filaments, form a network that spans across the universe. Matter tends to clump along these filaments, and galaxies form in these dense regions. The voids, in contrast, are the vast gaps between these filaments, regions where matter is sparsely distributed. But even though they may appear to be empty, voids are far from featureless. They are dynamic regions of space, with their own unique properties and behavior. The discovery of these voids raises a fundamental question: how can such enormous regions of emptiness exist in a universe that, according to our best models, should be uniformly filled with matter and energy? Einstein's theory of general relativity, which is the cornerstone of modern cosmology, suggests that the universe should be filled with a consistent amount of matter and energy, distributed evenly throughout space. In this framework, the expansion of the universe should be smooth and regular, with no large-scale anomalies like voids. But the observation of these massive voids indicates that something is not quite right. If voids this large can exist, then the assumption that the universe is homogeneously filled with matter may no longer hold true. Instead, we may need to rethink the very nature of the universe and the forces that shape it. The size of these voids is staggering. Some of the largest known voids span over 100 million light-years in diameter. To put that into perspective, the Milky Way galaxy, which is one of the largest galaxies in our local group, has a diameter of about 100,000 light-years. The largest voids in the universe are so massive that light, traveling at its fastest speed, would take 100 million years to cross them. These voids are not just gaps between galaxies, they are gigantic regions of emptiness that stretch across vast portions of space. The discovery of these voids is raising new questions about the very fabric of the universe. Are we dealing with a universe that is much more complicated than we realized? Could there be hidden forces at play that we don't yet understand? The presence of these voids is also forcing scientists to reconsider how galaxies form and evolve. In the traditional model, galaxies form along cosmic filaments, dense regions of dark matter and gas that stretch across the universe like a web. Galaxies tend to cluster together in these filaments, forming massive superclusters of galaxies. In the voids, however, there is little to no matter, and so the conditions for galaxy formation should be much less favorable. Yet, even in these seemingly empty regions, scientists have observed the presence of galaxies. Some of these galaxies are relatively young, having formed in the early universe, while others are older, suggesting that galaxies can form in these voids under certain conditions. This is surprising because it challenges the idea that voids are completely devoid of matter. If galaxies can form in the absence of the typical cosmic filaments, then what does that tell us about the process of galaxy formation? In addition to their size and distribution, the voids also pose an interesting challenge when it comes to measuring the age and distance of objects in the universe. Traditionally, astronomers have used a method known as the standard candle approach to measure distances in space. Standard candles are objects whose intrinsic brightness is well known, such as Cepheid variable stars or type Ia supernovae. By measuring how bright these objects appear from Earth, scientists can calculate how far away they are. This method has been incredibly successful in helping scientists measure the expansion rate of the universe and determine the distances to far-off galaxies. However, the discovery of the cosmic voids has complicated this process. The presence of these enormous voids means that the light from distant objects must travel through regions of space that have little or no matter in them. This can cause the light to be distorted or even delayed, making it difficult to accurately measure the distance to far-off galaxies. The discovery of these voids is also forcing scientists to rethink some of the assumptions behind the Hubble constant, the rate at which the universe is expanding. The Hubble constant is a critical parameter in cosmology because it helps scientists measure the age of the universe and determine how far apart galaxies are from each other. For decades, scientists have used the Hubble constant as a benchmark for understanding the expansion of the universe. However, recent observations have revealed that there may be discrepancies in the measurements of the Hubble constant. The James Webb Space Telescope has provided new data that suggests the universe may be expanding at a different rate than previously thought. This raises the question, is the Hubble constant reliable, or are we dealing with a larger, more complex cosmic structure than we realized? The voids themselves may hold clues to understanding these discrepancies. Some researchers have suggested that the large-scale structure of the universe, including the presence of voids, could be affecting the expansion rate of the cosmos. If the universe is not as homogeneous and isotropic as we once believed, then the measurements of the Hubble constant may need to be revised. This would have profound implications for our understanding of the universe's age, its rate of expansion, and even its ultimate fate. In recent years, a growing number of researchers have suggested that the voids in the universe could be evidence of something even more profound, namely, the existence of a multiverse. The idea of a multiverse proposes that our universe is just one of many, each with its own set of physical laws and properties. According to this theory, the voids in our universe could be remnants of other universes or even gates that connect different realities. This is a mind-boggling concept, but it is one that has gained traction among some of the most prominent cosmologists and theoretical physicists. The idea of a multiverse suggests that the universe we see is just one piece of a much larger, more complex structure, and the voids may be the key to understanding how these universes are connected. Moreover, the presence of these voids raises another possibility. Could these empty regions be the result of supercivilizations manipulating space and time? This concept, known as the Kardashev scale, proposes that advanced civilizations may one day have the ability to control entire galaxies or even reshape the fabric of space itself. Some researchers have speculated that the voids could be the result of such supercivilizations, altering the structure of the cosmos in ways that are beyond our current understanding. While this may sound like science fiction, it is a possibility that cannot be entirely dismissed, given how much we still don't know about the fundamental nature of the universe. As we continue to study the cosmos, the discovery of these cosmic voids is forcing us to rethink many of our most deeply held beliefs about the universe. From the uniformity of the cosmos to the rate of its expansion, the implications of these findings could be far-reaching. With the James Webb Space Telescope leading the way, we are likely to make even more astonishing discoveries in the coming years. The universe, it seems, is more complex, more mysterious, and more awe-inspiring than we ever imagined. And the more we learn, the more questions we uncover, pushing us ever closer to the heart of the greatest mysteries of existence.